Block foundations for rotating and reciprocating equipment are very common to all the civil and structural engineers in hydrocarbon, power and material handling industries, etc. In almost all projects, we come across various foundations for heavy pumps, turbo compressors, turbo generators, etc. Unless there is a process or functional requirement of placing them at a certain elevation, we normally opt for reinforced concrete block foundations on ground, else go for elevated framed structures. Here, various pros and cons of the two methods have been stated in tabular form. Here is the beginning of discussion on the new method of time history, which utilizes merits and eliminates demerits of both the methods. Firstly, the mentioned soil parameters and foundation dimensions are to be obtained to start with. Combined weight, mass moment of inertia, and location coordinates of center of gravity are to be calculated and organized as analysis inputs. Excel tables may be used for such calculations as shown in the book by Barkan. Then, effective radii of the foundation need to be calculated. With all the previous inputs, embedment coefficients and soil spring constants are to be calculated. Similarly, mass or inertia ratios are to be calculated. Similarly, embedment factors for damping are calculated. And values for calculation of geometric damping ratios are computed. Then, geometric damping ratios are calculated. Total damping ratios, that is sum of geometric damping and internal damping, are calculated. Internal damping is considered approximately 5% and the total damping should not exceed 20% or as specified in the code. Here is the diagrammatic representation of mechanism of vibration of foundation, including translation and rocking or pitching. Equilibrium equations for translation and rotation. Matrix notation for 2 degrees of freedom, that is translation and rocking. Mass matrix derivation for 6 degrees of freedom. Stiffness matrix derivation for 6 degrees of freedom. Damping factors. Damping matrix derivation for 6 degrees of freedom. Forcing functions. Derivation of total force vector for 6 degrees of freedom. Time history analysis by Wilson Theta method. sample graphical outputs of amplitudes of displacement and amplitudes of velocity. It may be noticed that at a specific time step, when the displacement is maximum, the velocity is zero and vice versa. This is exactly what should happen for a simple harmonic motion. As displayed, all the above steps may be programmed in MS Excel or MathCAD to obtain results of the time history analysis using Wilson theta method. The length of the program codes is very concise in MathCAD 15, but could be a bit lengthy in MS Excel VBA.